This video looks at a situation that can happen when we're doing a math problem when one of our variables is a year, or for some other reason one of our variables has very large numbers. This problem has data for the years 1990, 91, 92, and 93, and the question is saying, what is my y value going to be in the year 2030? 40 years after the data started. The issue is that a student can do all of the calculations using these numbers and correctly get the answer to the problem, but the large numbers, like these years, can cause mistakes. It makes the calculations a little bit harder to look at, and it's easier to make a punching error in your calculator or something like that. Here we've solved the problem, and you can see that in the first calculation to find the slope A, the large numbers didn't really inconvenience us very much because we ended up quickly with a slope of 11 over 1. Then I used algebra to finish answering the question, and that's where the large numbers started to be a little bit more inconvenient. This is one way of finding the equation of the straight line. It's not the only way, but these large numbers create inconvenient situations no matter which algebra method you use. At the end, once I found out that my straight line equation was y equals 11x minus 21,877, I plugged x equals 2030, the year 2030, into the equation so that I could find the y value and answer the question. My answer was 453. Now I'm going to show you a simple little trick that you can do to make the problem of numbers that are too large go away. What I'm doing is I'm remaking my table of values, and I'm changing 1990 to year 0. So my x's are 0, 1, 2, and 3. My y's are the same values that I have over here, 13, 24, 35, and 46. I realize that it's a linear situation because there is a constant difference. 24 minus 13 is 11, 35 minus 24 is 11. I keep getting 11. That tells me this is linear, and I want to use straight lines math. So finding my slope A with these numbers, I have 24 minus 13 in the numerator and 1 minus 0 in the denominator. I get the same slope, 11 over 1. But that wasn't where the problem of the large numbers had come in. Moving on to the next step, I'm putting in the point 0, 13, and I'm cross multiplying. I'm using the same method of finding the equation of a line, the same algebra method that I used over here. Y minus 13 equals 11 times x minus 0. Y equals 11x plus 13. Now I need to plug in the year, but this is the only extra step that you have to do if you decide to simplify your table of values by starting it at year 0. I can't plug in the year 2030 as my x. Since 1990 was year 0, 2030 will be year 40. I have to plug in x equals 40. So y equals 11 times 40 plus 13. Y equals 440 plus 13, which is 453. I get the same answer that I got with the first method, and it is the correct answer. This doesn't only apply to linear situations. You could be dealing with a table of values that turns out to be a quadratic or exponential or a step function, but could have years as one of the variables, usually the x value, or for some other reason could have very large numbers. And you can do the same sort of trick to adjust your table of values. Just make sure that if you do it, you adjust the number that you're plugging into the equation in order to get your answer as well. So you do have that one extra little step.